So building on what you learned last year of 1-point perspective, we're now going to start a unit on 2-point perspective. I want you to look at this image of how to draw a cube in both 1- and 2-point perspective, and I want you to notice the difference. What do you think the difference is between the 1-point perspective cube and the 2-point perspective cube? The difference is with the 1-point perspective cube, the cube is facing us. We're looking directly at it, and we've got one vanishing point. With 2-point perspective, we're looking at the corner of the cube. That's the part that we see first, and we have 2 vanishing points leading off into the left side and the right side of the image. This guy does a much better job of explaining it.
Here are some tips on basic understanding of perspective. Perspective is all about depth, and you get this with 2 main things: the horizon line and vanishing points. The horizon line is basically your eye level, and all lines showing depth converge to a point or points on that line. These points are called vanishing points, and they describe what 1-point, 2-point, and 3-point perspective are. We live in a 3-dimensional world, so a good image is always going to show length, width, and height. A 1-point perspective is going to have the length lines going to a vanishing point, and the width and height are just going to stay straight. A 2-point perspective is going to have the length lines going to one vanishing point, the width lines going to another, and the height is just going to stay straight. So a 3-point perspective just has 1 point for each of them. A simple way to keep these straight is the following. A 1-point perspective is looking right down the street. A 2-point perspective is looking at that corner, and a 3-point perspective is looking at the top of a building on that street corner. 1, 2, 3.
Let's see what that looks like in practice in a real photograph. So here's a photograph that clearly shows 2-point perspective. I know that it's 2-point perspective because the first thing I see, the first thing that's facing me, is the corner of this building. So let's look at where the horizon line would be. We know the horizon line is where the land and the sky meet. There's our horizon line. That's pretty obvious here. Now, in order to determine where our vanishing points are, we're actually going to use our converging lines. Here you can see an example of a converging line starting from the corner of this building and moving towards our horizon line. Just with that one line, I can already create my vanishing point. Let's add some more lines just to confirm that the vanishing point is correct. So here you can see I followed the edge of this building, leading to my vanishing point. And here's a few more lines which also follow the exact same principle. They start from anywhere on the page, and they angle towards the left vanishing point. Now you'll notice that anything that's on this side of the building, on the left side of the building, leads to the left vanishing point. Whereas on the right side of the building, we actually lead to the right vanishing point. Now you'll see here I've followed that converging line, but it actually leads off to the edge of my page. So I'm going to show you here, if I zoom out a little bit, my vanishing point is actually falling off of the page there, and that's okay. I know it exists, it's off of the page, but I know it's there. Let's add some more converging lines. So there they are. They continue from the right side of the building to the right vanishing point. Let's look at another example. This is a drawing that's done with 2-point perspective, similar to what you guys are going to be doing, although you're going to be adding a lot more creativity. Let's see if you can figure out where the horizon line is when we don't really have a land and a sky. So you can probably assume, because you can pretty clearly see the 2 vanishing points. And we know our horizon line, our vanishing points are always on the horizon line. So I just assumed that that's where my horizon line is going to be. And I'm assuming that these are where my 2 vanishing points are, right at the edge of the page. So this time they're not outside of the image. Let's see if that's correct by tracing some converging lines. So here you can see I've added a converging line from the top edge of this building, which also happens to pass through the top edge of the windows on this building and almost hits the top edge of this building here. Again, this is all the left side of the building leading to the left vanishing point. Here's some more examples. And I'm sure you could assume that on the right side of the buildings, they're going to lead to the opposite vanishing point. There's just one more thing I want you to notice here, and it's going to become more clear when you practice drawing cubes. But if I go ahead and I create a converging line on this building, as I mentioned, the right side of the building goes to the right vanishing point. But this building, you can see the left side of the building very clearly. So The left side of this building goes to this vanishing point, the left vanishing point, okay? Even though it's on this side of the page, it's the left side of the building, so it goes to the left vanishing point. Same with this line along the bottom edge here of this building, also leads to the left vanishing point, as well as this line here. Let's look at a few more examples. Here's an interior. You can see very clearly the converging lines leading to the vanishing points. The vanishing points here are probably somewhere off this page, but that's okay, it's still clear. Here's an image using a building. Again, we're looking at it from the corner. Vanishing points are definitely off the page, but you can see everything on the left side of the building is leading to the left side, right side of the building is leading to the right side. Here's another example. And here's one last example.